So particularly for your diploma or maybe multiple choice tests from us, we're just going to go through some other categories. You're not going to be drawing these. I'm not going to assess you in drawing them, and I've never seen the diploma assess you. I'll talk about the structures, but it's largely the categories. So in the first biological molecule I want to go through are your trifatty acids. Okay? We have a polyester type of chemistry, but it's just happening 3 times. So glycerol is a 3-carbon alcohol, and each of the carbon has an OH group. So it can do that esterification or that ester linkage on each carbon. And that can react with carboxylic acids, and that the length of the acid piece will vary in length. Okay. So I wrote, I missed an O at the very beginning. Now we have that carboxyl group. So we have the carboxyl group CH2N. Okay. And you probably don't have to do this in high school, but in university biochem, you have to memorize the name of all these fatty acids depending on how many carbons there are in the backbone. Okay. At one point, I knew a bunch of names. I've long forgotten them, but it turns into just a straight memorization. Has anybody done these already in high school, trifatty acids? Hasn't come up in bio yet? Okay. So the product, so you have the 3 carbons from the alcohol, okay. And then you're going to get an ester linkage. And that's going to happen on each of the carbons. Okay. So in terms of terminology, trifatty acid is the polymer, and you got glycerol and just the fatty acids as your monomers making this up. The second example of biological polymers is going to be starting with amino acids, and then you can put 2 of them together, and then you can put tens of thousands of them together and build up DNA. Is everyone okay with the fatty acid? So I'm not going to draw these. I got a few questions about drawing them in your workbook. I'm not assigning those questions. It's not worth doing for this course. There are 20 different amino acids that are the building blocks of life, or the memory part of life. In university biochem, you'll have to memorize all of those, which ones are acids, which ones are bases. You maybe haven't had to do that yet. Okay. What do you call when you put 2 amino acids together? Has anybody done that? They're your dipeptides. Sorry, Aaron. Okay. So you're not fully a polymer yet. If you put, again, tens of thousands of units together, you get a poly. peptide. So I want you to be familiar with our monomer, our polymer, and the two that you need to be familiar with. So you've got DNA and you've got RNA. Okay. You could see these terms. Okay. Often these are a matching. You may get a whole list of humble-jumbled list of monomers and polymers, and they might ask you for what is a monomer-polymer pair. You might have to say number 1 on the list, amino acid, and maybe DNA is number 6 on the list, and you have to pair up 1, 6 as the correct answer. You got to get the right pairing, and you've got to get the right sequence. Same thing with the example above. Okay. We're going to do this exact type of thing so you can identify the monomer and polymer when you're eating sugars. Okay. Carbohydrates and cellulose. Okay. Our monomers are monosaccharides. You can put 2 sugars together and get a disaccharide. Or put a lot together and get your polysaccharide. So a few specific examples of monosaccharides: glucose or fructose. Glucose is probably something that everybody's familiar with. The polysaccharides, your carbohydrates. That humans can consume, or your celluloses, your grasses that, you know, cows have enzymes to break down, but humans don't. It's still a polysaccharide. So your pastas are your carbohydrates, are a whole bunch of sugars put together. Sometimes called complex carbohydrates. It takes longer for our bodies to break down the carbohydrates. We get the energy more slowly than if we just have a whole bunch of simple sugars. And we get that energy quickly, but we also get the sugar rush of monosaccharides. Okay. So again, same here, be able to connect, get lists, you know, glucose, monomer, carbohydrate, polymer. Okay. One last thing I wanted to do that I just didn't have time to fit in, that kind of goes way back with the solvent extraction or the physical properties, is just end with talking about cracking. Okay? And this is really important to the Alberta energy industry, again, because often what comes out of the ground is not what customers want to buy, so you often have to break compounds down. So maybe the starting material is a C20H42. And your Suncor, and you just can't sell a lot of C20H42. That's not what people want. Okay? So you may run it through a process, heat, pressure, and crack it, break it up into a couple pieces. Now, there's not one answer for how it's going to break. So I'm just going to put up one example. It'll be balanced, and you just need to identify that if you start with one big molecule and you break it into 2 pieces, that is cracking or hydrocarbon cracking. So identify it as a reaction type. Okay. So maybe I'll split this down to a C11H22. And now we're getting into a product that we can sell that'd be close to either diesel fuel or gasoline. Okay? So we're into one of those, go to the gas station and buy products. Okay? And so what's left over? C9H20. You'll always find when you crack something, you don't get this. If you have an ane, you don't get two anes. You get varying pieces when you crack it. Okay. So you might start with an ane and get an ane and an ene. So this is just, again, one example, but if you see big into two pieces, you need to be able to identify that as hydrocarbon cracking. And again, very crucial to taking what comes out of the ground and making it sellable. Particularly in Alberta, a lot of the oil sands are going to have a lot of longer chain hydrocarbons, okay, compared to Saudi Arabia, or light sweet oil is going to have more smaller chains. They maybe wouldn't have to refine it as much. So that ends this section. I don't have any more extra questions to give you. That's organic chemistry. You've got some time today to work. You've got a paper quiz tomorrow in class, so it's not on a computer. It's pretty much all short answer, or it is all short answer.